Hello everyone, and welcome to the Innovative Farmers webinar on using Bokashi in animal production systems. Just to let everyone know, we are recording this. Your cameras are all off, so that's fine, but just so you're aware. And also, if anyone has to miss any of it, you can always catch up on a recording, which we'll put on YouTube and let you have the link. Great, so I'm not going to introduce the speakers. I'll let Audrey do that better than I am, but I'll just introduce Innovative Farmers to everyone who doesn't know what the programme is about. Basically, it's an on-farm research programme, and we support farmers and growers to run their own on-farm trials, or what we call field labs, on innovative and agroecological practices. So I've been doing it for about 14 years now. We currently have roughly 20 ongoing field labs, a lot of which are concluding at the moment, and they'll all be concluding over the next year or so. So we've got lots of interesting reports coming out of those trials, and all of those will be available on the website. But we're also, at the same time, we're launching some new learning networks, which are essentially field labs with extra resources for carrying out extra learning activities, with extra sort of networking capacity as well. So the 4 that we've launched at the moment are going to last for about 3 years, and we've also got some funding to launch some new ones. So if anyone's got any great ideas or wants to get in touch about topics for learning networks or at the field labs, do get in touch, and Matilda will put the contact details in the chat. We've got some great speakers today. Basically, this webinar is based on primarily on one of the field labs which we've been running on Bokashi and livestock manure, and this field lab was coordinated by Audrey Littrick, who will introduce the trialists and the other speakers much better than I can. But we've got a couple of farmers who were trialists in that field lab, and we've also got Andrew Sincop from Agriton and John Seed, who's a regenerative poultry farmer as well, speaking. So that's great. Before I hand over to Audrey, I'll just put in that email address there, so do get in touch if you've got any ideas for more on-farm research. Okay, right, Audrey, I'll hand over to you. Just stop sharing the screen.
Okay.
Oh, sorry, I did forget to say, do put questions in the chat. Sorry, that's the main thing. Questions or discussion items in the chat, and we'll keep a look on it. Keep an eye on it throughout the session.
Thanks very much, Laura. Okay, well, this has been a really exciting project from start to finish. I had several farmers come to me asking about Bokashi manure management. They called it lots of different things, but Bokashi was the one common word. About 4, 5, 6 years ago, and I thought it's time that we actually had a closer look at it. So that's what this field lab's about, really. So this is the final meeting for our 3-year project, and in some ways this project has actually raised more questions than it has provided answers, but we'll discuss that as we go along. Okay, next slide, please. I'm not seeing the next slide.
Sorry, Audrey, one sec.
Sorry, something's gone wrong with my Zoom. Completely crashed on me today, and I'm not able to share my presentation or see myself, so that's always a bit worrying. I can't see anybody else either, so hopefully this should work.
We're also not seeing the next slide.
I'm just going to stop sharing and retry. It seems to be a little bit sticky. Sorry.
Oh, dear.
If you just I'll keep going with the presentation, and hopefully it will get back up. So at the moment in the UK, most manures are stacked outdoors for maybe anything between 3 months and 2 years before application to land, sometimes longer. And most heaps are stacked uncovered. That's the way things are done still. And in most cases, they're not turned, other than where the farmer is moving them. So clearing the cattle sheds, and then just popping the dung back into spreaders and then spreading it on land. So it's generally not turned in a methodical way. And where attempts are made to encourage self-heating, through mixing and turning, that heating's usually patchy and short-lived. So we do see cases where manures get very hot, particularly on the outer layers, and some cases set themselves on fire, in fact, which is not ideal, very far from it. But that heating is usually very, very patchy throughout the pile, and it doesn't last for very long. Next slide, please. So we do have some problems with traditional manure management strategies. There's a high potential for ammonia emissions in the housing, in the cattle housing or the animal housing, and from the heaps to a lesser extent, but particularly during movement and spreading. And there's potential for losses, gaseous losses, particularly methane, but also nitrous oxide and carbon dioxide. And there's also potential where those heaps are stacked outside over the winter, particularly when the weather's wet. There's potential for losses of other nutrients as well, particularly the soluble nutrients, so potash and more nitrogen as well through nitrate leaching. We also get poor reduction in numbers of weed seeds and animal pathogens, and also fairly poor breakdown of veterinary medicines, pharmaceuticals, and also things like weed killers, which might have been applied to grass, which the animals have then eaten. The nutrient losses are highest in uncovered heaps. That does make sense. Next slide, please. So we've got increasing concerns over carbon dioxide emissions, carbon footprinting, resource use, also the sustainability of farms. And my goodness, that is extremely pertinent at the moment, because we're looking to conserve as much nitrogen in particular on the farm as we can. And we're looking to use less nitrogen because prices at the moment are only going one way. Policymakers are very much onto some of those concerns, but not necessarily all the best ways of dealing with them. Next slide, please. So this project is really about Bokashi manure management, which is a somewhat different way of managing manures. It's a fermentation technique rather than a simple stacking, and it's certainly not composting either. Next slide, please. So the technique was developed in Asia Pacific countries by a guy called Professor Teruo Higa, and this technique and all the associated work with microorganisms, with EM as he calls them, which is a registered trademark, is much better known in Asia Pacific countries, and it's much more widely used in Asia Pacific countries than it is here. It's also quite widely used in Africa. I've been out there looking at, not as part of this project, but out there looking at uses of EM in multiple different spheres, including some very unusual ones, things like wound healing in gangrenous patients, for example. So it's where you might think that's completely ridiculous, but it's not. It actually has been shown to work quite well. So it's EM's used in a wide range of applications, but it's not all that well known in this country. Next slide, please. So what Bokashi manure treatment is, it's deliberate inoculation of livestock bedding or of the bedding plus the manure with a blend of specific types of bacteria and yeasts and fungi which thrive in anaerobic conditions. And these microorganisms then go on to colonize the bedding or the farmyard manure, and then break down, to some extent, the complex organic materials in a particular way. And it's a fermentation process. It's very similar to that used to produce silage or kombucha, for example, or sauerkraut. It's more like that than the kind of anaerobic breakdown which produces methane, which you often do get in anaerobic environments, things like anaerobic digestion, for example. It's completely different to anaerobic digestion. It also, I really rail against the use of the word composting alongside Bokashi, because composting has a specific meaning in this country and in many other countries. Composting is an aerobic process, and it relies on the kind of bugs, microorganisms which thrive in oxygen. And Bokashi very much doesn't. It's a fermentation process which only works properly when air is excluded. So this is why I tend to call it Bokashi manure treatment or Bokashi fermentation rather than composting. Next slide, please. So what about the advantages then? Well, the theory is, and there's increasing scientific evidence to show, that if you're fermenting manures, certainly rather than composting them, and rather than allowing considerable methane generation, you should have an improved carbon footprint and a much more sustainable manner of managing your manures. You should be able to reduce ammonia emissions, and ammonia gas emissions are a major problem for the environment, and the regulators are very much onto that. But it's also a really major problem for farmers as well, because ammonia emissions equals nitrogen losses equals you having to buy more fertilizer, or crops perhaps not reaching their full potential. So we should be seeing, with a well-run Bokashi system, reduced ammonia emissions, reduced losses of carbon and organic matter, because every time a molecule of carbon dioxide is emitted into the air, we're effectively losing it from that manure. We're losing organic matter from our manures. Ammonia is not a greenhouse gas, but of course many of the other three main gases that would be emitted from a manure heap would be carbon dioxide and methane and nitrous oxide. So the theory is that we should be reducing greenhouse gas emissions if we're covering the manure heap and treating it with Bokashi microbes. So we've got improved reduced greenhouse gas emissions. The theory is also that we should be improving manure properties and increasing the manure fertilizer value. Well, we can discuss some of that. There's also theories and very much growing evidence that there's practical and animal health benefits. So many farmers are reducing the odours in the housing and reporting a much more pleasant atmosphere in the housing. There's also, should be, in some cases, reduced requirement for bedding. Are there any other benefits? Well, we're not so sure. Next slide, please. So this field lab was basically intended to have a closer look at some of those things. Some of them are very complicated to look at, but some of them we have addressed really pretty well. Next slide, please. So I'm sorry, I don't know why those slides are not showing up properly. They did on my screen. It's very odd. Early indications suggested that Bokashi manure treatment has got very good potential in the UK here, but we do need more evidence, and more evidence on the practicalities and also on the costs and the benefits for farmers in terms of animals. Are there any benefits for animal health and welfare, for example? So next slide, please. Looking at the summary of the field lab, it was a 3-year trials programme of 2 Scottish livestock farms, a dairy farm and an upland livestock farm. We also did a literature review aimed at defining what the current scientific knowledge actually is, and my goodness, that was quite a challenge. I'll say a little bit more about that later. We also wanted to chat to UK farmers who've tried or are trying Bokashi manure treatment as well. Next slide, please. So the aims of the field lab was to look for any practical benefits to animal husbandry, look at ease of handling and spreading the Bokashi manures in comparison with the farmer's standard manure management system. We looked at the quality of manures. Are they any different if you've used Bokashi or not? The total financial value, we looked at that as far as we could. The time and cost of manure treatment, we certainly did look at that. Carbon footprint, there's very little we were able to say about that. Unfortunately, we'll explain why. Lots of theory. It's more difficult and very much more expensive to get hard data on that. And also a little bit about resource implications in terms of fuel use and the additional fertilizers required on the farm. So I don't want you to have to sit and listen to me all day. Let's hear from some of the people who've got direct experience. So first of all, we're going to hear from Andrew Sincock of Agriton, who's selling some of the materials to make Bokashi. And then we're going to hear about from 3 farmers who've been using Bokashi over the last year, 2 years, 3 years, 4 years in one case, about their direct experiences of using Bokashi. And then I'll finish off by summarising the findings from my point of view about what we've learned in the project, and then we'll have hopefully some time for questions. So over to Andrew Sincock first.
I think you might be on mute, Andrew, sorry.
Unmute. Here we go.
There we go.
So how are we looking there? Can we see everything that we need to?
Yep.
Yeah.
Perfect. Right. Oh, I can't see my screen now, which is good, isn't it? That's a good start. There we go. So yes, thank you very much, Audrey, and very, very pleased to be part of this project, this conversation, and this webinar today. Bokashi has become a bit of a sort of love affair of mine, to be honest with you, or composting in general. So I want to just sort of set the scene and explain to you guys when I first heard Bokashi, my sort of thought process, what I instantly or sort of related it to, and why I got quite excited about Bokashi and why I'm still quite excited about Bokashi. So as Audrey's mentioned, the first thing really that I thought about when I was told about this fermentative decomposition and had it explained to me was, well, it's the principles are the same as making silage. And the conversation that I have with my farmers, whenever I'm on farm, whenever I see an image like this in front of me, so we've got a manure heap here, is, well, why are you doing that? What's the reason behind doing this by putting your organic manures in the corner of a field in a heap? And the conversations was, well, we leave that in the corner of a field for 12 months or 6 months or however long for it to rot down. And that key phrase is really important. It's to let it rot down. And my answer, my sort of retort is always the same. What would happen if you took your first cut silage and put it in the corner of a field in a heap for it to rot down before you fed it to your cows? Would they eat it? Would there be any nutritional value left in it at that point? And of course, the answer is no. Yet we do it with our organic manures. The principles are the same. With silage, we produce an excess of nutrients in the spring and the summer months that we want to feed to our cattle, our livestock in the winter months. In the winter, we produce an excess of organic manures, of nutrients that we want to feed to our soils in the spring and the summer months. So how is the best way of preserving those nutrients from one period of time to another to ultimately feed the soil? And everybody says, well, yeah, of course, feeding the cow is very different to feeding the soil. And I would beg to differ. I think the two are very similar. And in both situations, you've got microorganisms breaking down complex organic structures into their constituent parts to drive yield. So the same thing, the same function is happening in the soil that's happening in the ruminants, in our digestive systems. So the way in which we treat them should be very similar. And annoyingly and unfortunately, we don't. And as Audrey sort of touched on, we can actually see, we can physically see the losses that we are experiencing as farmers from our farms. And in these two pictures, we can see very clearly we've got leachate, we've got effluent running out of the manure heaps, which is all of our soluble nutrients that are going to be driving yield that year. We've also got volatilization of nutrients into the atmosphere. As we can see here, we've got steam, we've got water vapor, we've got carbon dioxide, we'll have potentially methane and nitrous oxide, all being lost into the atmosphere. All of these nutrients that we're losing, farmers are then having to pay good money to replace. And that to me just seems absolutely crazy. So the difference between Bokashi and other forms of composting that are being taken place on farm is this, as far as I'm concerned: rotting versus fermenting. Think about your first cut silage. Think about your lawn clippings. Think about how quickly they heat up and how quickly you lose nutrients, they lose palatability through poor management. So Bokashi, silage, Bokashi, the principles the same, the theory's the same. What we're trying to achieve is the same. We're trying to preserve nutrients to feed to animals later on. A little bit of work that's done and that we get quite excited and that I quote about quite often was this paper that was done by WETSUS, which is a European Centre of Excellence for Sustainable Water Technologies. I'm not going to delve into it in too much detail, but I've highlighted the key point here, which I'm going to hopefully visualize with the next couple of slides. The brown shapes that you see in front of you, you've got three of them: anaerobic digestion, Bokashi, and compost. That brown shape represents the starting material. So that is the amount of carbon, in this instance, we're looking at carbon, in the starting material before it has been put through three different processes. The red shape that we now see in front of that brown shape is what's left at the end of it. So looking at that peer-reviewed, independently done trial, these are their results. Anaerobic digestion, so AD, we're losing 36% of the total carbon. With aerobic compost that has actively been turned, we're losing about 75% of the total carbon, whereas Bokashi, it's just 1%. So we see a significant reduction in the losses of carbon, but also nitrogen, phosphorus, potassium, etc. Now, what does that mean for you guys as farmers? How can that benefit you? Well, when we look at soil analysis, after 3 years of continuous application of different products, in this instance, we're looking at a control that's received nothing, to compost, to Bokashi, we can see that 3 years of compost and Bokashi has resulted in different soil organic matter percentages. Compost has increased the soil organic matter by just 0.1%, whereas Bokashi has seen a scientifically significant increase in soil organic matter from 4.6% to 5.2% in just 3 years. Everything else was the same. And we can also see, when we look at the fertility of the soil, in this instance nitrogen, that continual applications of Bokashi has increased both available and nitrogen stock within the soil. So we see we're increasing both soil health with regard to increasing organic matter, but also increasing soil fertility through the increase of nutrients such as nitrogen. So just a few last slides from me. When it comes to the practicalities of making, there are a number of different ways. Now, the guys that are going to talk to you have created and come up with a way that suits them and their system, but there are a number of different ways of making Bokashi. This is an example of how we make Bokashi at Groundswell, where we always have a Bokashi heap on demo, where we are adding organic matter, or we're layering, organic matter with a number of amendments. In this instance, we've got a seashell grit and we've got a volcanic rock dust to add additional minerals. And then we're adding microorganisms and layering again, right the way up until we can cover it and ensile it, and we're leaving it for 8 weeks. We could apply those microorganisms directly into the bedding, and this is by far and away the easiest and cheapest method of doing it. Once a week, walking through the shed, knapsack sprayer, watering can, microbes directly onto the bedding. Now, Audrey also touched on some of those additional benefits. There are a number of studies that have been done, again, in Asia and Africa, this one in Pakistan, looking at the inclusion of effective microorganisms and their ability to reduce pathogens. So we've looked at E. coli, Salmonella, Pasteurella, for example, and this particular study showed that effective microorganisms, were effective at reducing the incidence of those pathogens within animal housing. Another one here done at the university in Egypt, Cairo University, again showing that the use of EM has the ability to inhibit the growth of pathogenic bacteria. So the microorganisms, the inclusion of beneficial, effective microorganisms can reduce the potential impact of pathogens within that animal housing. Once you've applied those microbes, take them out and cover them. It's already been touched on. The guy here at the bottom has got really excited and obviously has lots of money because he's been able to put it into an ag bag machine, which I think is extortionately expensive. Last year's silage sheet works really well. And I want to leave it with this. And I want to thank everybody for attending today. And as the slide says, giving a shit about your shit. And how we can manage that moving forward, I think is really important. And trials like this and the work that Andrews, John and Audrey have done just highlights the value that organic manures have and why you should consider them as the valuable resource that they are, as opposed to a waste product that you've possibly been treating them as up until now. Thank you very much.
Thanks very much, Andrew. That was excellent. Most people involved in this project are called Andrew, it seems. Andrew Barber, would you like to go next and explain what you've been doing on your farm?
Julie, yeah, thank you. Hello, everyone. And if Matilda can ping up the first slide, she's going to share for me because I've never ever get this thing to work.
Can you see the slides?
No, I can't.
Oh, I could see it. I can see that. Can anyone else see that?
Yes,
No.
it's an innovative farmer slide.
Yep.
Yes.
Yes, we can see that.
The first slide should be Mains of Fincastle. I'm not seeing it.
Oh, I'm not seeing that one.
No, that's okay. Are you seeing the one with your name on at the moment?
I'm seeing the one with my name on it. Yeah.
Perfect. That's absolutely fine.
Yep. Okay, let's go to the next one then.
Thank
That's
you.
it.
Okay, so here's an overview picture just to give folks an idea of Mains of Fincastle. It's Fincastle is a 500 hectare upland unit west of Pitlochry. So we're looking towards Bennyvrackie there, just to give folks a picture of it all. Next slide, please. So we are an organic upland beef and lamb producer. These other terms are the kind of things that we get quite a lot of visitors to the farm and they are interested in these other things that we do as management techniques that we use in our organic system. Until you come to the last one, and until innovative farmers came along, and Audrey in particular came along, and we talked about manures, no one has ever expressed any interest at all in, well, actually even the cows, but certainly the manure they produce and how we handle that manure. So that was something we were interested in, because in an organic system, you're wanting to maintain you're wanting a cyclic system rather than a linear system, as I'm sure folks understand. So next slide, please. And just a word on the cows. We have two herds of small herds of outdoor wintered cattle, but the main herd is indoor wintered, and we start with a Highlander. We put a white-bred shorthorn over it, and that produces this type of cow, which is a Great Hill cow. Put Limmy back over that, and then we put, if we go to the next slide, we will put the white-bred shorthorn back over that, and you get that type of commercial cow, not too big, reasonably hardy, with a Limmy as the final hybrid, as the final crop. And this is the main herd on the main bit of the farm. And we go to the next slide. So we are interested in the use of wood chips to produce long-term lignin source for feeding the fungi in the soils. And we were particularly interested in how this would react with Bokashi treatment, or the best way we could treat the manures. So we were really starting to focus on what happens to this stuff when we put it on the ground. And we go to the next slide. And so this is, you've seen lots of slides of this kind of thing already. This was our traditional farmyard manure, sat in corners of the field, as the previous Andrew said, and we could see the nutrients running out of it. So we knew we had to do something about this. So the first stage was to cover, using silage sheeting. But that didn't stop what you kind of see here, the fungal decomposition and heating either to the hot or the very hot on the outside layers. So we got interested in Bokashi, having read about it through, I can't remember how, and we had started a small-scale trial, really looking to see if we could retain more nutrients, if we wouldn't get this heating, and how it would interact with the wood chips. As I said, we're interested in boosting our phosphate levels in the soils as efficiently as possible. And so Audrey's visit here was very timely from our point of view. She's going to, I think, we'll talk about the results that we got, but the first year results comparing Bokashi treated manures with wood chips in them with the non-treated gave us indications that we were retaining more nutrients. We certainly had a nicer product and we weren't getting the heating. The second year trials, we didn't see the same difference in nutrient retention. There didn't seem to be any difference between the two, but we certainly were still getting a nicer smelling product, easier to handle, and less smelly, or not smelly actually, quite sweet smelling. So next and last slide. Yeah, so we've moved into a system whereby we treat it, we do a layered system in the shed. It's a shallow bedded system, so we clean out every 6 weeks. We now sheet this with a tarpaulin because we found in our situation, plastic silage sheeting, we found it really difficult to handle, really difficult to keep it weighted properly. Just in an outdoor field, great in a silage pit, but we didn't have silage pits. At this stage, went ready to invest in them for this purpose. So this is the second year we've treated the whole shed with Bokashi on a regular knapsack spraying for the regular treatments, and prior to clean out, we're actually starting to use watering can because you put it on at a higher rate. So we're evolving our treatment and how we handle this stuff as we go. But we do see the benefit most certainly in the sheeting. That's the most crucial bit of it all. And the actual treatment using Bokashi is not a great extra expense on the system that we are running. What I would like to leave, and maybe we can discuss the things that we've found that are unknowns or we've had to develop ourselves. Yes, the very basic thing of how to most efficiently cover in our situation, cover the heaps, how to bulk up the EM material, the Actiferm material in a cost-effective fashion. And those are the two main areas that we feel we can build on and develop on. Monitoring what's happening in these systems is really difficult, but what we've landed up doing is using heat as the monitor of what's going on in the system, and we use difficult under a tarpaulin to measure, so we've started using thermal imagery. We use that for fox control, so we can see what's happening in these heaps using. It's not a very exact method, but it's a useful sort of hands-on method, if you like, crude method, to check and see what's doing in these covered heaps. And that, I think, is probably enough for me at this stage. I'll add one last thing. Since we've started doing the whole shed, we've started seeing more and more cows calving in the shed. Normally they have access during calving time to a set of fields, and they can choose whether they're in the shed or out in the outside. It's a choice system, if you like, and the shed becomes a feeding station. Cows have been calving in the shed. Is that something to do with odor? Is it why that change in behavior? Because Previously, they would always carve outside the shed. So I'll leave that thought with you and let the next Andrew move on to the centre stage. Thank you.
Thanks very much, Andrew. Next, Andrew Taylor, please, could you move in and explain how Bokashi's been working for you?
Yeah, no problem. Thanks, Audrey. So to rewind, I had heard, so basically we started, we're 170 hectare dairy and beef farm, so our milking cows, calving suckler cows, and we take everything through to finishing. We are grazing everything, paddock grazing, so everything get moved every third day, really. Dairy cows are every 12 hours, and we're up to 4 cuts of silage a year. So the biggest problem we had was what do we do with our FYM in terms of spreading it? We didn't want to bring it back in with silage, and we also didn't want to end up, what we're finding is if put it in grazed ground, you tainted the grass, and the stock always ate the bit that you'd miss when you were spreading because of the taste. So we were looking a way to break it down, to make it easier spread, and not be bringing it back in with the silage. So that's how I got looking, and was very fortunate to meet up with Audrey at a meeting and ended up on this system. So we tried. So first year Bokashi, we split the shed up. Every second bay got treated, and then every other bay was a control. We then tipped them in a pile to 2 piles, sheeted one up, left the other one totally as if it was just a standard system, tipped in the field and left, and tested. However, come the second year, we decided to go a bit further. So what you can see here, we had 5 piles. So we had Bokashi sheeted, then a Bokashi unsheeted, a control sheeted, a control unsheeted, and the final pile was a traditional composting pile. So this was really to try and tell what's going on. We've try and cover all the variables there to really see what's going on. So that's the shed you can see in the background is the shed that it was in. So that's calves from once they're weaned until they're about 12 months old. They're in that shed, dairy cross calves. Okay, next slide, please. So I'm very fortunate my neighbour also has a telehandler with weigh scales on it. So we're able to weigh the piles in and weigh the piles back out before they were spread on the field. It was quite interesting when we opened the piles of Bokashi. They looked fairly similar. However, anecdotally looking at what was in the field, it certainly broke down a lot quicker. And I would say, like what Andrew said, the sheet really is the key. Locking in that moisture and getting the bugs working, having the sheet on, it really helps. So yeah, that's how we treated it there. Next slide, please. So I'm very fortunate that, very fortunate or unfortunate, we're a very heavy farm, high rainfall. So in terms of tipping, FYM in fields doesn't really happen. So we have a roof store, and then we have another concrete store without a roof. And so what we've been doing since, and continue to do, we are taking the cling film off the silage pit and putting it over the pile. As we fill the pile forward, we pull the cling film forward. And the cling film, just like when you put it on the silage, it gets sucked down and it creates a really good seal over the top of the FYM. And it's amazing just how much moisture that is retaining when you pull that back. And it's really, really doing a tremendous job in there. So we love it. It's tricky to quantify. Audrey will go into the results of what we've seen. In terms of cost effectiveness, we have a lot of digestate available on from not that far away. If we can pick it up at £1.50 a tonne, £3 a tonne during the summer, a lot of nutrients can be bought for not a lot of money. However, when you start looking at the other benefits, I think from Bokashi, in terms of you're breaking it down, and I guess it's a lot of things that we can't measure. So in terms of biological activity, for example, what's going on in the soil, all that stuff going forward, I think there is something there with using the Bokashi. So yeah, I say not all of these, we're very fortunate to have a store like that, but I think it's a great way and it's pretty simple. So in terms of applying the bugs, we went with a watering can once a week and just spray them across the shed. I think going forward, we've got a straw bedder, so it probably look at fitting something to the straw bedder just to save time, to make the job quicker and make it easier and more repeatable. So next slide, please. So yeah, that's that's where we're farming again. Just photos back to front, but to give some where we are. So we are in Mauchline. That field there's our dairy cows. We're all tenanted, and some of the ground we farm is Mosquito, where Robert Burns was. So that's our cows, dairy cows grazing on where Mosquito is. We're Nestle farming, so through First Milk. So it's a lot of regen. We do a regen plan. We have the full farm soil carbon cored down to a depth of 1 metre, and they'll be repeating that again next year to really quantify if the actions we are doing are putting more carbon into soil and hopefully reducing our carbon footprint. Cow type, we are a 3-way cross with the dairy cows, so they're a Holstein cross to the fleck weight, then cross to the Norwegian red, and then back to the Holstein again. We're aiming for a medium-sized cow, and we're going to an autumn block system, so we're aiming for kind of 7,500 litres, which we're doing at the minute, sort of 4, 7, 4, 8 fat, 3, 5, 3, 6 protein, somewhere in about there. Just trying to get as much off of grazed grass as possible. And then in terms of the suckler cows, they are simmentals out of the dairy cow, and then they're either put to the simmental or the Angus bull. And as I say, everything that's not used for breeding gets taken right the way through to finishing, with as much either grass or silage as the predominant part of the ration. Okay, next slide, please. And so that's us there. As I say, that's really the workforce, myself and my dad. So anything we do, anything we are trialing, labour is a big part of it. We're pretty busy running what we are already, so it needs to make it worthwhile for us in terms of time. Which again, as I say, the first time I tried the Bokashi on, I tried it with a knapsack and realised very quickly I was going to spend a lot of time. So quickly moved to the watering can, and I think again the next step is to move to something fitted to the bedder so that it's simple, it's repeatable, and it's probably just be a case of filling up a tank once a week and letting the system go on with it. So yeah, that's us. See if there's any questions at the end, we'll be happy to answer what we're doing. Yeah, thank you.
Thanks very much, Andrew. That's excellent. Now, for a very different sort of farm, John Seed, who's got a regenerative poultry farm. If you could say a bit about your system, please, John.
Sure. Hopefully you can see the slides.
Yep.
Yes. So this is where we are. We're in the Merse of the Tweed. It's on the east coast, the far easier area to farm in, perhaps. So that's looking over to the Cheviot Hills from the top of the Lammermuirs, and the River Tweed's in the middle of there. It's an NVZ, so the rules are particularly strict, and this is our farm here from the windmill. There's a 32,000 bird free range egg unit, and we produce our own feed so far as possible off the ground round about. And our aim has been to, we're regenerative, we're trying to increase carbon content, we're trying to, and effectively we're farming the biome is how I would describe it. And we're trying to be resilient, and we're trying to reduce the cost of fertilizer, which is even more important nowadays. Because it's an NVZ and poultry litter's very hot, a lot of uric acid, you're limited to be putting on 5 tons per hectare per year because of that. Whereas if you go down the route of Bokashi treatment, then we're able to apply it according to what the crop needs. The other thing that I was very acutely conscious of, we have a shed to store the manure in, so it is in covered storage, and I'm following Andrew Taylor towards the thing of making Bokashi in pits. But you could tell when you went in the loss of it, because there's such high uric acid in poultry litter, the loss of ammonia was eminently noticeable. It's hygroscopic, it tries to run out the door. So this is the hens at Wood End, and one of the things about it is that nothing's magic. Agriculture is fundamentally extractive. So when we're selling 30,000 eggs a day and malting barley and oats, we're taking a lot of nutrients out all the time. So the more making efficient use of the nutrients we have makes real sense as well. And this is why we did it, Bokashi. But this is where we've mixed it with chopped straw, and we've applied a a bucket of Agriferm to the product before we bagged it up. This is the first year we tried it. I listened to Andrew's comments about ag bagging, so I'm going to show you an ag bagging machine, but we're having to give that up for it's expensive, but also because it's a lot of plastic involved and a lot of handling. But anyway, so this is what we do: is we take the muck out of the poultry shed every day. We take 8 tons a week out. One of the issues is we need a lot of carbon to make the Bokashi work. We take in wood chip from power line maintenance and other things as a byproduct, and we use a lot of that. And then we use straw. We either use our own straw where we're keeping the Bokashi ourselves, or we get straw that would have been chopped back from our neighbours. And so people get their own straw back, because I'm acutely aware that grass weeds and weeds are always an issue. Plus, I don't want to be buying straw. And so we bought a second-hand feed mixer to do this with, because we were always taking 4-ton batches out of the sheds twice a week. And it's easy to put it in that, drop a bale and shovel some wood chips and pour some Bokashi, some of the Agriton stuff in. And it has evolved, not least because the gearbox broke in the machine that we had. But this is what we did last year. And we put it into an ag bag machine. And that was the only way I could do it with the space we had and the time. Because as has been already said, labour's the thing that's hardest to deal with. So we stuck it in an ag bag and we tested it and sent it away to be tested over a 12-week period. And you can see when it comes out, I don't know if any of you have ever seen poultry litter running at the door of a shed, but it's hellish stuff. This is fantastic. The difference was extraordinary. It smelled sweet. It was, if that's possible, you wouldn't believe it. And it was drier. All the tests, the carbon had been used up. It was fantastic. It was a real revelation to me. It was so much better than when we put it in. It was slobbery muck like you saw in the bucket, and when it came out, it was great. And then we went on, because it's now a known compost, because it's no longer got readily available nitrogen in it, because it's been used up by the bugs and as they digested the straw. We're able to apply it to a growing crop of wheat in March and April, which is what we're doing at the moment. And we can apply, well, what we do is we do soil testing, we do leaf analysis, and then we work out what we need to put onto the crop. This is a crop of wheat after beans. You can see the stalks of the beans with direct drill. We don't do any ploughing at all. And this is great. And we're looking at putting a set of a springtime harrow through that just to incorporate it a bit. We're adding biochar this year as well. So we are trying to build the carbon content as we go. And you have to learn as you go. The machine breaking down certainly didn't help. But we're now doing it we've just separated our manure store into 2 halves. We're using the sheet because it's inside. We don't worry about it blowing away. But it's important that it's airtight, and we keep trying to make it work better. We're learning as we go, and we're trying not to spend any more money than we have to do. So we're as I say, we've got 2 300-ton bales, 2 300-ton bays, and compacting it and doing it as part of the taking manure on a regular basis has been important. I have a friend nearby who's a dairy farmer and another one who's a pig farmer. And whenever I go to Duns after we've spread the poultry litter, I used to say, well, it wasn't me, it was Willie, or it was somebody else. But people don't like that sort of thing. So now it's a lot better when you're spreading Bokashi treated poultry litter than it is doing other stuff. There's no ammonia volatilization. We're getting far better retention. And you can see it in the nitrogen compound, and we tested it with Audrey. We tested it after every 4 weeks once we put it in the bag just to see how it evolved. And it just, one of the other problems with poultry litter in particular is you're limited to 5 tons a hectare, but you're limited in an NVZ as to when you can spread as well. And you end up in that crazy situation where the weather's not ideal and you're lashing poultry litter onto stubble and then trying to sow green cover crops in September. You might as well burn your money. So this way we're getting the fertilizer at the right time of year on the right crop, and we're making far better use of it. And we're gradually building our carbon anyway. But there's no doubt at all that having a more available and higher nitrogen product than we previously did and being able to put it on the right times made a big difference. And we sell it. There's a big market for poultry litter anyway. I did this before the Gulf blew up, so I think now that's probably getting towards £30 a tonne. And the biggest issue has been the straw and the labour. So we give people back their own straw, and it's straw that they would have had to chop anyway. So it's only the cost of baling versus the cost of chopping and a bit of haulage. And it's certainly reducing fertiliser costs, and that's more and more important. It's making better nutrient cycling, and it helps the soil from a lot of rain and everything else. And the other issue for me is that I'll come back to it at the end about carbon auditing and the way that it's treated, because there's a real lack of. The more I've done this, the more gaps there are in the knowledge, as far as I can see. So we collaborate with our neighbours. We sell the muck, they sell us wheat. We feed it to the hens, and so it goes. And it works really well in this area, and it helps to improve arable land, which has been dealt with. It all needs carbon. It needs its organic material built back up, and it's a holistic whole farm approach. And one of the downfalls of the carbon audit systems like Agriton and others is that they don't take account of that avoided nitrogen. They don't take account of the saved ammonia, the reduction in emissions and everything else. So you don't, at the moment, in my experience, get the credit for what we're doing. And we looked at getting SEPA to accept that doing Bokashi is a way of reducing emissions and ammonia emissions on farms. And they say because there's not been enough independent research done that they don't accept that. So there's a real gap in the knowledge out there. And it's those evidence gaps that are causing the issues in it. There's a lot of money in the, if you're Norsk Hydro or someone else and you're making fertilizer, you've plenty of money to get things accredited. But this use of Bokashi, where people are reducing fertilizer costs and saving it and keeping it on their own farms, keeping it locally, there isn't the cash to do that research, so it needs far more scientific validation, some of these evidence gaps filled. Ammonia reduction being the key one, but also about how much more nitrogen is available to the plant when it's been digested. Greenhouse gas, there's no acceptance of the benefits of Bokashi, so far as I've found when I speak to any of the people who do greenhouse gas monitoring. And soil carbon, well, it doesn't change overnight anyway. It's taken us 60 years to deplete it on this farm. It'll take at least 60 to build it back up again, doing things like this. So there's my wish list, which I thought I'd put up here because these are the things that I think need to be done and need to be done by with government support because it benefits the wider population, and that's where it is. And this is it. Bokashi for us has been great. It's not a solution in itself, but it manages the trade-offs of being in an NVZ, making better use, preserving the ammonia, improving the soil, and it certainly makes us more resilient. I would ideally like to have no fertilizer bill at all, but this has gone a long way to getting rid of it. And it's hard to explain to people the difference between Bokashi and open air composting, which is quite a bit of going on because there just isn't enough knowledge of the system and the benefits that are there because it hasn't been well enough researched. So that's us.
Many thanks, John. Well, that's excellent. Between the three farmers, we've got three very different sets of experiences on three very, very different farms. As far as the actual project's concerned, let's have a look at what we found. It's actually a very complicated subject to look at in a relatively short project because some of the work which we need to be doing to develop further information requires some very expensive equipment, which we don't have, and a very great deal of technical time, which we didn't have either. But we did learn some useful stuff. Next slide, please. So basically what I'm going to talk about briefly is the literature review we did to establish the level of scientific knowledge which we do have, and a little bit about the results of the trials what we learned and what we were not able to learn, basically. So as far as the literature review is concerned, there's lots and lots of stuff has been written about Bokashi. Next slide, please. Lots and lots of stuff has been written, but a very great deal of it is anecdotal. So it's people saying, we found this, we found that, but it's not based on scientific research. And a great deal of that information is from countries that are a lot hotter than the UK. Also, I kind of have to admit that the quality of some of the papers which I've found from those warmer countries, the Asia Pacific countries, the quality of the science is actually quite poor. It's not been necessarily very well written up, and it's not quite as rigorous. A lot of it is not in particularly high impact journals, unfortunately. Next slide, please. But we do have some useful information. Many farmers and Bokashi users are claiming much lower odours in animal housing, and I know we did. There was certainly some evidence. John Seed and also particularly Andrew Barber have been saying that, and I've noticed that myself. Not so much at Loch Hill, Andrew Taylor's farm, because of the way in which he was organising his trials. So it's a very, very valid scientific way of doing it, where you've got replicate treatments, and he had Bokashi treated animal manures and bedding in different places in the housing, which is a good way of doing it in some ways, but it meant that the odour reduction potential was not as obvious. We weren't really able to measure that because the treatments were all in there together, mixed up, in a relatively small area. But it really was very clear when I've used it myself at home here, and also when I visited Andrew Barber's place, how much the odours were actually reduced. So, but that must surely translate to reduced ammonia, because ammonia has got a very characteristic smell, and that smell just wasn't there. So we are clearly reducing ammonia emissions, potentially also greenhouse gas emissions, because ammonia is not a greenhouse gas, but we weren't able to say that. We're clearly reducing nitrogen losses overall, but we weren't able to measure that. Many farmers and also several researchers are also claiming that the carbon footprint of manure management is reduced with Bokashi systems. And that's so important at this moment, given the state of our planet and the pressure that farmers are under to achieve net zero, the pressure that our entire planet is under to achieve net zero. We're pretty certain that this is happening, but we need more definitive evidence than we've currently got. Some farmers, I would go as far as to say most farmers that are doing Bokashi properly are reporting that it's a more consistent product, which is better for spreading. It's easier to spread evenly across the field. Virtually everybody seems to be saying that. And I think Andrew Sincock of Agriton was telling me that basically he's pretty much lost count of the number of farmers in the UK that are using Bokashi now, and they're continuing to do so because it works for them. And this is one of the main benefits that they are seeing as well. Okay, next slide, please. So we've got some science-based information on improved carbon footprint of Bokashi manure treatment over composts. And that's very easy to prove, and it's pretty obvious. Composting, as Andrew Sincock said, composting results in some massive losses. So I do a lot of work with composting systems and commercial composters, and I would say we lose on average 40% to 60% of the mass during a composting process. That's normal, with huge losses of carbon dioxide. And if that carbon is going up into the atmosphere, then basically it's not available in the organic matter which is being applied to soils, in many cases for the purposes of building soil organic matter. So you're losing things there. Also, composting is a very energy intensive process. It requires a lot of turns, which requires a lot of machinery use, which means a lot of diesel use. So there's that aspect of it too. So it's very clear and well documented that composting is more carbon intensive than Bokashi. But what we really do lack is a comparison of the carbon footprint of Bokashi systems compared with standard UK manure treatment systems. So where a farmer is simply taking his manure out the shed, dumping it in a field and leaving it uncovered, there's no good scientific comparison of those two methods, and that's what we really badly need. In fact, we don't just need an assessment of the carbon footprint of those two methods. We also need to look particularly about the losses of individual gases and the losses of nutrients, particularly nitrogen, from those two systems. Okay, next slide, please. So we've got this fairly good information out there, a limited number of studies, but the studies are saying the same thing. Nutrient and carbon losses are lower where organic wastes are treated through lactic acid fermentation. In other words, Bokashi treatment, we're calling it, rather than composting. And it's leaving more carbon and more nitrogen in the finished material. So that means that there's a higher value for the total amount of nutrients, higher value of the fertilizer that the farm has available for spreading. And a reduced need, therefore, for bought-in nitrogen fertilizers and more carbon available in the manures in their totality, the whole pile, to help maintain and enhance soil organic matter levels. Next slide, please. But what we don't really know yet, and I'm afraid what our work was not able to show, we don't have enough information about the relationship between Bokashi versus traditional manure management techniques in terms of the nutrient profile within an individual ton of manure. Manures are, by their very nature, very variable. And even although we took 3 replicate samples of manures before and after Bokashi treatment and the other treatments, the results weren't really that clear. So we still saw quite a bit of variability, and we weren't definitively able to say Bokashi manure treatment results in, say, more nitrogen per ton of manure than it does with standard manure treatment, or more potash or whatever. So we definitely need to be doing more work on that, taking more replicate samples, for example. Okay, next slide, please. We also are seeing that there's very limited science-based information on the impact of Bokashi manures actually on soils and crops. Now, we were not able to do this. There wasn't enough funding in the project to look at soils, and to be realistic, trials of any organic material on soils really need to be going on for 5 years minimum, and we didn't have that. So we concentrated on testing the manures and looking at the farmer experiences and spending the money on that rather than spending the money on testing soils. We did look a little bit at soils, but we weren't able to do that in detail. And other studies have not really done that in a big way either. So there's limited hard evidence of the beneficial effects of Bokashi manures over compost or fibre digestate or standard strawy cattle manures, for example, in terms of the amount of crop available PK magnesium, crop yield, crop quality, and soil microorganism populations. There's a bit of evidence which is suggesting, and I find this very believable, that Bokashi manures are better at stimulating soil microorganisms. I'm not sure whether they're likely to be any better than standard strawy cattle manures, but I do think they would be better than composts, because composts, a lot of the kind of food value in a compost for microorganisms is kind of already gone by the time that compost is finished. Whereas it's only the fermentation microorganisms that are finished their job with Bokashi. There's still some very good food in a Bokashi manure for soil microorganisms. So there is some evidence that Bokashi manures are certainly better than composts at stimulating soil microbiological activity. But again, more work needs done, unfortunately. Okay, next slide, please. We did look at odours in cattle housing, we did look at ease of using Bokashi, and we did look at the costs. And all these 3 topics are reported we have a case study for both Loch Hill Farm, Andrew Taylor's farm, and also Mains of Fincastle, Andrew Barber's farm. So those case studies are on the website, and we've dealt with that in quite a bit more detail in the report. So we are, certainly Andrew Barber did find that the odours were much reduced and Bokashi was easier to spread. Both farmers are saying that they're finding the Bokashi is easier to spread and easier broken down once it's applied to soil. Costs, complicated really, but I think it's fair to summarise that in terms of cost-benefit analysis, Andrew Barber is definitely going to be continuing to develop his system and continuing to use Bokashi. Andrew Taylor sounds as though he's probably going to be continuing to use Bokashi, at least in the short term, and still is in the evaluation phase. Many farmers are continuing to use Bokashi in the UK because they feel it is worth the effort. So it's certainly a technique that's worth looking at. Next slide, please. As I said, we did look at testing manures before and after treatment. We're not really finding definitive evidence that there's a difference in terms of dry matter content. I would say depends on the season, and usually Bokashi treated manures that have been covered will be drier and will be easier to spread. That might be different in a dry season. In terms of total nutrients, total carbon to nitrogen, total carbon and carbon to nitrogen ratio, nitrate and ammonium, we weren't really finding definitive evidence of the differences between Bokashi treated and standard manures. More work needs to be done on that. E. coli numbers generally were lower in Bokashi treated manures than in untreated, but not always the case. Next slide, please. So we're not really finding clear evidence of the differences in manure properties between the start and finish of treatment either, or between Bokashi and standard manures at either farm. So what we really do need to do is further work. What we definitely can see is that the total value of a manure pile in terms of its fertilizer nutrient content is going to be more in Bokashi because you're seeing less losses. You're seeing far fewer mass losses in a Bokashi treated covered heap than in an uncovered heap. There is no doubt about that. And from that point of view, Bokashi is very much worth doing. Next slide, please. What Andrew Taylor did was look at the magnitude of mass loss. In other words, how much nutrient, how much mass is actually lost over 5 different types of manure treatment process. This trial was not replicated, so it was only involving very small amounts, maybe about 5 tons of manure, which isn't really enough to be certain. What we did see is that if you look there, there's the percentage weight loss during a 6-week treatment period. So by far the greatest losses there are the treatment on the right, the composted manure. That's pretty much guaranteed. Very large losses there. And the standard uncovered heap also lost quite a lot of mass. What's really odd is that the standard covered manure, as opposed to the Bokashi covered manure, actually lost the smallest amount of mass. Don't really understand why that would be. There was no obvious reasons. And both types of Bokashi lost about the same, whether covered or uncovered. And I think that's unusual too. But it just shows you how very, very difficult it is to draw definitive conclusions from trials on manures, which are inherently extremely variable. And those was not a replicated trial, and it was involving very small amounts of manure. It was still worth doing. Okay, to conclude then, from this project, as I say, it's next slide, please. One of the most important things to conclude is how little we know and how much more we really need to be knowing. This whole project underlined the combination of the literature review and the farmer work on the 2 farms. It underlined how useful this technique could be, what potential it has. Farmers like it, and they like it for good practical reasons, but my goodness, we need to know a lot more in order to be able to prove what I'm pretty certain the benefits actually are. So we certainly saw that the odours in the cattle housing were reduced. with Bokashi Manure Treatment, particularly at Mains of Fincastle, and also John Seed's finding that in his system. And basically, the more ammonia and uric acid nitrogen that's present in your manure, the more likely Bokashi, when used correctly, is likely to be able to reduce the odours in your system. The cost of Bokashi Manure Treatment varied widely between farms, and I think all the farmers that I've spoken today are saying, whoa, this could be big, this cost could be quite significant. And they, as soon as they started using it, they tried thinking kind of outside the box and thinking, how can I make this system work for me? Because it looks very interesting, it looks as if it's got potential, but I want to be reducing costs. So they're all working to develop the system on their own farms to make the costs more believable. And certainly Andrew Barber and John Seed are now saying it's worth it with the costs as they are. Bokashi Manure Treatment is making manures more consistent and easier to spread, and that's certainly a very important benefit. The manure quality, there is some scientific evidence that Bokashi Manure Treatment can reduce carbon losses and nutrient losses. We have been unable to demonstrate these benefits in this project, but there's enough scientific evidence to show that the benefits are there, and we need to know more in a UK context. Next slide, please. There's definitely the potential for Bokashi to form part of a broader solution to some of the most important challenges facing agriculture today. This is a policy statement. There's absolutely no doubt about this. And I can see what SEPA are saying. I've spoken to SEPA myself about this. They are very interested in Bokashi treatment, but they're saying we just do not have the evidence at the moment. And it's not up to a tiny little project like this to provide evidence like that. We're pretty certain that it could help reduce ammonia emissions, which is clearly a government priority. It could help reduce greenhouse gas emissions, which is a world priority. It'll help farmers conserve carbon in the organic matter and the manures that they're producing, and thereby it'll maximise the value of their manures when applied to land in terms of helping to maintain soil organic matter content. It'll also help the farmers to retain the nutrients in the manures, and thereby helping maximise the fertiliser value of the whole manure cohort on the farm, and reduce their requirement for bagged fertilisers. Well, everybody's in even more of a panic now than they were before about that. Even the simple act of covering manure heaps is going to help farmers achieve that. But I believe that Bokashi will help them take it that step further. Next slide, please. So there's sufficient evidence to show that potential. It's there. There's a clear need for further work. So we need detailed comparison of the relative advantages and disadvantages of that type of manure preparation in comparison with stacked, uncovered farmyard manures. We've got quite a lot of evidence to show that Bokashi manure treatment is better than composting, but actually very few farmers are doing proper composting with manures. And that's as it should be, really, because composting is not an easy technique to use with a relatively wet, relatively high carbon material. Bokashi is a much better technology for manures. And we need to be looking at greenhouse gases, ammonia emissions, manure quality, and nutrient carbon conservation. Looking at gas emissions is not something we could ever have done in this project. I've done that on 5-year DEFRA-funded multi-million projects where you've got very specialist equipment and very specialist technicians as well. This needs to be a government-funded, significant government-funded project, and I think it absolutely merits that. And if further research were to confirm these benefits, then agricultural support schemes could be targeted towards encouraging farmers to adopt Bokashi systems as multi-benefit manure management systems. Okay, next slide, please. So if further research were to confirm the benefits of Bokashi manure treatment, then we could see benefits not only to farmers themselves, but also in terms of our soil health, in terms of our carbon footprint, and in terms of our path towards net zero and reducing resource use on farms. So project outputs, my last slide here. we've got a final report, which is going to be available shortly on the Innovative Farmers webpage on Bokashi. We've got 2 case studies. The literature review there is there in full, and it's a bit of a monster. Thanks very much to John Seed for helping me with that. And thanks also to First Milk, who helped me write up, do the extra work, help test, pay for some of the testing for the extra work, which Andrew Taylor did, and help bulk up the literature review by looking at the value of his work in the context of the Innovative Farmers project as well. We've also got a summary of the benefits and challenges of the different manure strategies that are used on UK farmers. So that's I've just put the URL there in there for that project webpage. So now let's move on to, we've got a bit of a time for discussion and question and answers.
Audrey, I don't know if you can see the chat because you're having trouble seeing the screen, aren't you? So
should I can't see any of the chat. So if you just
read out some of the questions,
just read out some of the questions and direct them to whoever you think might be best placed to answer them, because we've got 3 farmers. We've got Andrew, who's got a long experience with using Bokashi and with helping farmers to develop Bokashi systems on their farms, and then there's me, who ran this project.
And there's a lot to talk about. That was so interesting. Thanks everyone. That was brilliant and really highlights those variables and those complexities of trying to study this in a scientific way. But lots of questions. So we'll just start in the Q&A section. Andrew, doesn't say which Andrew, how does the wood chip break down with the Bokashi? I think that's probably Andrew Barber, who's been working with wood chip, isn't it? So if I start with you, Andrew Barber.
Bokashi doesn't touch the wood chip. It has doesn't seem to have any impact on it. The wood chip, we were worried, would stay in the field and you would get into the next crop, or would take time to disappear. In actual fact, we found that the wood chip, you couldn't find the wood chip in the sward after a couple of months. It's a full male wood chip, it's a fine wood chip. But we couldn't see any impact of the Bokashi treatment of the wood chip going into the covered heaps and then coming out again. So the answer to that question is that it's neutral in terms of impact. So I don't know if Audrey would have any comment on that.
Or John, I agree with you. I agree with you completely. Yeah. There's a bit of magic going on, I think. In a composting system, you have lignin decomposing fungi, basically, which do break down the woody parts. In fermentation and also in anaerobic digestion, there's pretty much no lignin decomposition of the woody materials. But my goodness, it gets kick-started as soon as that material is applied to soil. And my theory for that is that there's so much good food for the soil microorganisms, which is in the Bokashi, that the minute that Bokashi manure hits the field, it feeds the organisms in the soil, which can break down that woody material. And it just, as you said, Andrew, when that material is applied to soil, it just seems to disappear within weeks.
Brilliant, thank you. Andrew Sincott, you were typing an answer to that. Did you have anything else you wanted to add to that? Or
yeah, I'll just simply say that it depends on the carbon to nitrogen ratio. If you've got enough nitrogen, you can break down any carbon. If you do not have a balanced carbon to nitrogen ratio and you have more wood chip carbon than you have nitrogen in cattle manure, and I'm assuming, because I've not been to Andrew Barber's, so I don't know, but I'm going to assume that if you've got upland cattle on a predominantly hay-based diet, you aren't going to get an awful lot of nitrogen coming out the back of the animal. So you are going to have a lack of nitrogen in the bedding in that situation. But once it's applied out onto the field where we've possibly got more access to nitrogen, there's obviously nitrogen within the soil. The biology can actually start working and breaking it down. Anything can be broken down in a Bokashi heap or in anaerobic fermentation, assuming the carbon to nitrogen ratio is correct. Wood chip, 400 to 1. Cattle manure at Andrew Barber's might be 15 to 1. So we're way out of balance there for it to break down in the bedding. If John Seed was to apply wood chip into his poultry manure, given that there's an awful lot more nitrogen there, I suspect you'll see a pretty good and rapid breakdown even within a Bokashi heap.
Yeah, we use wood chip. We get quite a lot of it and put it in. It disappears. Our problem is getting enough carbon in to make it work properly. So it needs a lot of wood and it needs a lot of straw. And no matter how much we put in, I don't think we're ever putting enough in. We try our best, but so yeah, it does disappear. But that's because of the high available ammonia, nitrogen in the uric acid in the poultry litter.
Brilliant, thanks everyone. Neil's had a question about the metrics, but I think we've probably answered that question in Audrey's part at the end about what metrics were being used. But Niels, if you want to re-ask that, do. And were there clear findings at John Seeds? So John wasn't part of this specific trial, but you were doing your own, John, weren't you? So I think you've sort of summarised a lot of your findings, but we weren't doing the same protocol at John's because he wasn't part of that main trial. Unless you wanted to add anything, John, on your findings.
No, we did more soil testing and material testing than perhaps you did in the other trials, but it just followed what you would hope and anticipate by the process of lactic acid fermentation. And it's about getting the recipe right, I suppose. The only other thing, we've talked a lot about ammonia emissions, but the elephant in the room in Scotland and the UK is manure at the moment, and it's not ammonia emissions that exercise SEPA and the Environment Agency, it's nitrogen deposition, particularly in vulnerable sites. And that was why we spoke to SEPA, was about trying to minimise nitrogen deposition and also runoff of phosphate and other nutrients. And the lack of independent evidence meant that they couldn't accept it, even though it's clear that because it's an anaerobic fermentation inside a bag, you can see it by testing that ammonia is retained and that nitrogen is retained, so it's not being deposited. So it's about the recipe and about having a proper anaerobic fermentation.
Brilliant, thank you. Patricia asked a question which has been partially answered in the chat, but it would be worth just talking about it in general. If you have dairy slurry, can you use Bokashi to somehow stabilise it? And how is it done? And I think Andrew's put in some details as well, but I don't know if anyone else wants to add anything to that.
Well, we didn't use dairy slurry here, but I think Andrew at Agriton has experience of using Bokashi as part of slurry systems, haven't you, Andrew?
Yeah, so slurry sort of bugs, slurry biological products aren't new. There are a number of them available on the market. King's Hay did a trial a few years ago, I want to say 2012, possibly even 2011, so several years ago now, looking at dairy slurry and microbial inoculants. The general finding was that there was a retention of nitrogen, so we lost less nitrogen to the atmosphere through the inclusion of microbial products. We also saw a reduction in crust and just generally a more homogeneous slurry that had a better nutrient profile and was less toxic to the soil. So slurry can be quite toxic. The introduction of biology reduces that toxicity, keeps your earthworms alive, basically. So it is a really simple, effective way of reducing toxicity and improving the slurry more generally. EM and other microbes will do a very good job at doing that. Yeah, and it is actually quite a low cost and a pretty good return on investment with those figures having been done and already calculated.
Brilliant, thanks, Andrew. Richard asks, if we only have one muck heap, is it safe to open to add more as we muck out various sheds at different times?
I'll just say that the picture I had of the roof midden, so it's filled and we keep filling it forward. And what we do is we put the bit of cling film right up on the top, and as we fill it, we just go up and move it forward every time. So it can be done, and then once that midden's full, then sometimes obviously it's first in, last out. The way they style of pits work, but as long as it's given time, once it's in, then it should be fine. I think
Brilliant.
the big thing with that is you notice it from day one, from the minute you put that sheet on, and it's getting that sheet on and keeping it moving. It's the amount of moisture that that sheet can retain. That moisture's there, and it's allowing the biologist to do something rather than drying out, forming that crust in the top.
Great, thank you. Any more questions just while we have a look back through the chat? Has anyone put a system on a spreader bale to add microbes whilst bedding up?
Yes, I've seen that. So there are a number of straw choppers, straw blowers. So I know Kuhn and I believe it's Teagle do a dust suppression system where they literally just spray a fine mist of moisture onto the straw as it comes out the blower. Spreader bale don't have a specific system, but we have people that would apply the microbes directly onto the bale before it goes through a spreader bale or even through a straw chopper. We've also got farmers that have retrofitted using a simple silage pump or something along those lines to be able to introduce the microbes directly to the straw. And that's what Andrew Taylor's looking to do, is a retrofit or a purpose-built one.
Yeah, no, a 12-volt pump is very cheap, especially compared to what some of the systems are costing to get fitted to the straw bedders. So yeah, 12-volt pump, it does need to be fancy.
Brilliant. Okay, well, we've got probably no more time for questions. So I just wanted to say, firstly, there will be a recording someone has asked. It'll go up onto YouTube, and we'll send you an email just with a link to that, which obviously feel free to share with anyone or go back and look at if you've missed anything. We're also just about to post a survey, just because we have to justify spending money on things and justify to our funders. So if you could take a second just to have a look at that survey and just quickly fill in a yes, no, too early answer, that would be really helpful just for us to feed back to our funders and just check that we're on the right lines with our webinars. And if you have any other questions, do feel free to contact us on the email address, which is at the top of the chat, and we can forward them on to the panelists and find out some answers for you. So just remains for me to say thank you very much to all our speakers today. It's been so interesting, and I think it just highlights that clearly there's a lot going on here. There's a lot of potential, and a lot that still needs to be asked. It's great that we're able to get everyone and talking at the same time and have questions and the opportunity for people to ask you about your own experiences, as well as hear from you yourselves. So thank you very much. And the report is online, the case studies are online, and the website has been shared in the chat. So thanks very much, everyone, and have a great afternoon.